Hi, everyone, and welcome to Delivering Business Outcomes with Digital Twins. Feel free to come up. There's plenty of room up here in the front. If you are exploring the concept of digital twin and are trying to discover how digital twin is impacting businesses and you want to see examples of that in action, then you've come to the right place. I'm Brian O'Flaherty-Wills. I'm the worldwide go-to-market lead for AWS IoT TwinMaker. So what that means is I have the privilege of working with some of our most innovative customers, positioning AWS IoT TwinMaker and helping them to make a business impact using that service. So I want to talk to you today about four things. First of all, I want to start with why now? We're hearing more and more customers ask us and investigate digital twins. So what is it that's driving this interest? What's driving this wave? Second, I want to talk about broadly what we're hearing from customers in terms of business value, both the what and the how. What are those keys to unlocking business value? And then third, I'll dive into some examples, real examples of our customers impacting their businesses with digital twins today. And then we'll look at partners as well. So before we get into why now, it's important to actually level set on what is a digital twin. I'll say right away that I'm not here to say what is a digital twin and what isn't. There's lots, as you know, of various interpretations of the term digital twin. What I want to do, though, is level set for this discussion on how we view digital twin. And so for us, digital twin really encompasses four things: a physical system or an asset, a digital representation of that asset, and a connection between the two, and a business outcome. There's a couple of key pieces to this that distinguish this definition from some others. So first of all, that living physical virtual representation being dynamically updated, what does that mean? So for us, a digital twin is something that actually has a connection to the real physical world. It's something that is hydrated with data coming from sensors, coming from cameras, coming from enterprise systems. The other aspect of being living is that that digital twin has to live through the life cycle of that physical asset. And in many cases, our customers are thinking about digital twins of factories, buildings, plants, the kinds of things that live on for decades. And so when we think about building a digital twin and we think about managing through the life cycle, we need to think about how to manage the change that goes on in industrial operations and mimic that in the digital twin. So why the growth and interest in digital twin? Why are we having more and more discussions with customers and partners around digital twin? Well, as technologists that we know that anytime we see cost and complexity being driven down in enabling technologies, what we see is a spur of innovation up the stack. And I would propose that really a part of what's happening with digital twin now is that we're seeing a drive in innovation, removing cost and complexity from four key areas. So the first of these is sensors, and I think if you're in the audience and you're coming to an IoT presentation, you're probably already well aware and bought into the idea that we can get data from the physical world much cheaper than we could 5-10 years ago. But in addition to that, it's the complexity that's come out of the equation. So bringing data at scale into the cloud, thanks to AWS IoT services and partners, has become much, much easier. We're not doing any more the heavy lifting of managing the security and the scalability of that communication. So that's one. The second is connectivity. And if we think about where we were 10 years ago with wireless connectivity and cellular, and where we've come to with 4G and now 5G networks, much more bandwidth, much more capability for massive data collection at scale. The third piece is modeling, and by modeling, what I mean is a couple of things. I mean modeling in the sense of predictive models to predict behavior of our physical assets. And so by this, I mean basically AI, ML, but also physics-based first principles models that we're doing more and more of in the cloud. The other aspect of modeling is spatial, and the idea that we can get better spatial context on our assets than we could a few years ago. So there's a ton of innovation around spatial compute, around being able to capture the built reality that our customers have and bring that into a digital twin. And then the final piece, of course, is at-scale compute. And for this, it's at-scale compute in the cloud to deal with all this data, but it's also at-scale compute at the edge. So these are the four kind of technology enablers that we're seeing drive innovation in digital twin. And I want to give you an example of the kind of application that this is enabled. So in the audience here, put up your hand if you're familiar with Amazon Go. Okay, most of you are familiar with Amazon Go. To recap, Amazon Go is a just walk out retail experience, a store from Amazon. The concept is really that simple. You walk into the store, you identify yourself through an app or even with your palm of your hand. You grab what you need. In my case, recently, I was visiting the Seattle headquarters, running late for a breakfast meeting, ran into Amazon Go, grabbed my breakfast burrito, grabbed my yogurt, out the door, 30 seconds. So no lineups, no cash, no checkout. So big business impact. What it may not have occurred to you or even to me at the time was that we think about Amazon Go and you think about that definition of digital twin that we had a second ago. This actually really fits pretty well. So we have a physical store. We have a virtual representation of that physical store. That virtual representation contains information about the space, the items on the store, the human beings walking around the store, how they interact with that space. And it logs it all to drive a business outcome. And the business outcome was Brian getting his breakfast burrito in 30 seconds. And I would submit that if you think about those four technology enablers, first of all, sensors. So Amazon Go, not only the sensors on the shelves themselves, but the cameras. If we think of cameras actually as a type of sensor, the imaging and the image recognition at the edge that drives that awareness, that understanding of what's going on in the store is something that you couldn't have achieved at cost even 5 years ago. If you think about networks and the amount of data that we're collecting at the edge, the amount of data that we're transmitting to the cloud at scale, if you think about modeling and if you think about the spatial understanding that's being used to drive our awareness and also our ability to predict and understand behavior of human interactions in the store, all of this really counts towards a digital twin. So I think this is a really good example that I like to use with our customers. If this kind of thing, this kind of awareness is possible today with those technology blocks, think of what's possible in industrial operations. So Amazon Go is a great example, but it's not necessarily a representative example of our customers. So I want to kind of turn now to where our customers are going with digital twin at a broad level, and what they're telling us are the hard parts of digital twin that are really going to unlock business value. The first thing I want to examine is the who for digital twin. And it actually turns out this isn't a simple question to answer, because when I walk into and talk to customers, the definition of digital twin, what it means and what it drives, actually depends a lot on who I'm talking to. So if we take an example here, I'm kind of taking an example of personas in a manufacturing operation. If I talk to production engineering, so the process engineers who drive the actual process optimization on the shop floor, what they're really interested in is basically optimizing that operation, optimizing the recipe, getting the most output out of a given set of inputs. And so for that persona, a digital twin is really about problem solving. It's really about, hey, I'm not performing to the specification I want to. I'm getting an anomaly. I'm getting substandard performance. I want to understand why. I want to understand what's causing it now. I want to understand what factors led up to that. If I talk to operations and maintenance, the plant manager, the plant owner, or the maintenance technician, it's really more about removing context switching. So there's so much going on, so much happening around the plant, lots and lots of data all stuck in silos. It's really about trying to understand how these points of data relate to each other and really getting a 360 view of that operation. And then our customers are also investing rather in data science, right, and trying to understand big picture view of what's happening at the operational level. And here, it's really about contextualization of data. It's really about querying across data sources. It's about search. And so, what we can see here is that for digital operations, for that persona whose job is to drive outcomes for all of these user personas, it's a tough one because you're really trying to serve very different needs with that same digital twin concept. So, the takeaway from this slide is that it's not a single pane of glass solution that our customers are looking for. It's really different applications, but built off a single digital twin. If we look at actual business outcomes that our customers are trying to drive, there's lots of different ones. I've tried to synthesize some of the most common ones I hear about and I speak to customers about here. And again, you can map this to the slide that we just saw in terms of those user personas. So if I take that top row, that's really pertaining to industrial operations, manufacturing, and energy customers. And really we're looking at how to improve the performance of our asset, of our plant, how to enhance productivity, and by that I mean productivity of our skilled workers, operators, and technicians, and how to connect remote experts. A lot of these plants have engineering inputs, design inputs coming that are remote from the plant, and it's really being able to bring a full 360 awareness of that plant operation into those remote experts. Another big sector that we spend a lot of time with is building and public sector and the built environment. And here, the big concern is around how to make buildings, public buildings, more palatable, more comfortable, safer for tenants, especially after the COVID pandemic. That's a big focus for our customers. Buildings are also operations unto themselves with lots of equipment, lots of systems to manage. And so improving field service and making that more efficient is an important priority as well. And then everybody, industrial operations and building, is really thinking right now about how to improve and manage and reduce ultimately their carbon footprint. All of these are valid digital twin business outcomes that our customers are looking to drive. So again, a very diverse picture, different users, different outcomes, different industries. Where it all comes together though is on this slide, which is really where we get very, very consistent feedback, regardless of what industry and persona I'm speaking to. What are the hard things on digital twin? What are those 3 keys to unlocking business value? The first and most consistent point of feedback is this: data in industrial operations lives in silos. Accessing that data and just getting that data and bringing it into an analytic workload for our customers is an area where that requires a lot of heavy lifting. And so our customers are spending a lot of time just getting at these data sets in silos. And that can be, of course, SCADA equipment, sensors, cameras, but also a lot of enterprise systems, manufacturing execution systems, work order systems, maintenance systems, all of this coming together. And then we get into that second bucket, which is really, I've got all these systems, these different data sources, and I need to use them to model my asset. I need to model a factory process. I need to model a building. And I have these different data sources that are representing that same process or that same building in different ways. And so what needs to come together is kind of a semantic view of the asset that is taking these different data sources and mapping them into a single knowledge graph or a single representation. And that's a huge lift for our customers right now. They're spending a lot of time, a lot of subject matter experts spending a lot of time tagging, reconciling, loading, and basically working through these data sources to create that model. And then the final piece is visualizing this and serving this up in applications. And this is an interesting one because depending on the persona we speak to, there's a different level of visualization needed. A lot of process engineers who are used to seeing their industrial operations in a 2D P&ID diagram or a floor plan don't necessarily need that 3D perspective. But for the majority of users and the majority of human beings, we interact with the universe in 3-dimensional space. And so having a contextualized view of the asset in 3D really ends up bringing a lot of context and driving a lot of value for our users. And this is a challenge. Why? Because our customers have 3D assets in the form of CAD files, in the form of building information models or BIM, in the form of scans and reality capture. So they've got that kind of source data for 3D, but what ends up being really hard is taking that source data and turning it into a simple web application that you can serve to an average user at scale. There's a lot of proprietary data formats. There's a lot of challenge in converting those data formats and really turning them into a web-friendly or a mobile-friendly application. So that's a big challenge as well. So remember this slide. We're going to come back to these 3 keys to unlocking business value as we go through our customers' examples. What I do want to say is that when we launched AWS IoT Twin Maker at reInvent last year, we have in mind the idea of removing some of the heavy lifting around those pieces to unlock that business value. So AWS IoT Twin Maker is a service that allows our customers to access those data silos, those data sources, and bring those data sources together at scale in a knowledge graph, in a model that allows them to model their entire asset, their entire process, and then to map that onto the spatial world with their 3D models, their 3D assets, and serve that up to users at scale. So let's get into some actual examples of this working. Favorite part of my job by far is working with industry-leading, innovating customers who are really driving innovation on AWS and experimenting with digital twin. And I want to talk about 3 examples today. Invista, Carrier, and Jaw in Holland, all from very different industries, all driving very different outcomes with digital twin, but all ultimately looking to unlock that business value. So let's start with Invista. So Invista most likely is a company that you're not familiar with. But Invista is one of those companies that makes products that we use every day. Invista makes chemical intermediates. So what I mean by that, Invista takes raw materials and processes them into fibers, resins, thermoplastics that we use in vehicles, that we use in kitchen appliances, that we use in car airbags. We use them in pantyhose. So we use them in all kinds of applications. And they're very good at this. Invista is a world leader in what they do. And Invista, what makes them really interesting for me is the innovation culture, very, very innovation-minded. We already have some great success stories with Invista on AWS. And when we met with Invista last year, they came to us with a challenge. And what they said was, look, we have really skilled operators. We have really skilled technicians in our plants who are acting as human sensors and actuators. There's an alarm, there's an alert. They spend time figuring out what it is. They spend time going to the machine. They spend time diagnosing the alert. They spend time tracing back to see, okay, well, what happened in the week, the month prior? What's happened in terms of the maintenance schedule of this machine? Is any other machine exhibiting the same behavior? What maintenance is planned? What replacement parts do we have? There's just a lot of context switching between systems to be able to run their factory. And so what they told us is we really want to build a system. We really want to build a single view for our skilled technicians that gives them all this data in context. And they call this the connected worker. So the connected worker application, the vision they brought to us, can we bring data from our SCADA equipment, which is already running in the AWS cloud? Can we map that and tag that to our asset information, our asset hierarchy? Can we drive alerts, and can we build some of our other systems in place and bring them into a single contextual view? So we started to work with Invista to drive towards this connected worker solution. And I want to kind of connect what's happening here back to those 3 keys to unlocking business value. So you take the first one, data sources and accessing that data. SCADA, data from control systems in the factory environment coming into the AWS cloud and hosted in our partner solution, Snowflake. We're able to access that information. But we're also able to access information about their asset hierarchy. So basically in this industrial operation, as you can see, this is really the kind of industrial operation where you don't actually see a lot of what's happening. A lot of the mixing, a lot of the processing is actually happening in pipes and in tanks. So understanding the relationship between all of those pieces of equipment and how they feed into each other is vital. And what Envista told us is, hey, we've spent a lot of time building up this understanding. We've spent a lot of time tagging and associating and modeling our assets, and we don't want to do that over again. We want to use that in a digital twin solution, our connected worker solution. And so with AWS IoT Twin Maker, we were able to read from that asset hierarchy and build an understanding, a schema to represent the entire factory operation. And then finally, visualization. And so what you're seeing here on the screen is an early version of the application that we're building with Envista right now. On the right-hand side, you can see time series data coming through. In the middle, what you see is a reality capture where we've overlaid parts of that knowledge, so parts of that schema onto that 3D picture. And that 3D capture came from a vendor, a partner of ours called Matterport, who I'll be talking more about later. So again, this was an example of Vista saying, hey, we've got these really good scans of our factory environment. We want to reuse those. We don't want to do this again. We want to be able to combine the data from our operational systems with this 3D view. And that's what we've been able to do here in this application. So again, this is an example of those three aspects unlocking business outcomes. What are the business outcomes that we're driving here? So first of all, again, highly skilled, trained professionals in the operational context. We're removing a lot of context switching for them. So we're allowing them to do less sensing and actuating, more problem solving on the shop floor in the factory environment. Envista has done some modeling on the present value that they think they can drive out of this business case. And they're talking about in the millions and tens of millions of dollars over time by, again, reducing this context switching and allowing their employees to do what they do best, which is solve problems. We've also got environment, health, and safety impact, obviously being more aware and having more contextual information of what's going on in operations is going to help. And another big piece of this is what Envista calls citizen developer, which basically means we want to empower, we want to drive empowerment for our operators and our technicians to be able to work with data, and this interface is providing them with that as well. Context switch here. So I want to talk about Carrier. Carrier, some of you are probably familiar with the name. So Carrier is one of the largest vendors of heating, ventilation, air conditioning systems, HVAC, but also fire security and refrigeration transport. Carrier is really leaning into innovation as well and is building with AWS and a whole set of IoT capabilities to be able to bring digital services to their customers. And that's important because a quarter of Carrier's revenue today is coming from services and aftermarket. So as Carrier serves their customers, they need to know more about what's going on with equipment, what's going on with their systems, and how to best maintain and support their customers. So the challenge the Carrier has is if you think about HVAC systems and you think about all of the buildings that we have and all the legacy systems out there, it's really a heterogeneous environment. I mean, in a manufacturing plant, you normally at least get to standardize on a single vendor or a set of vendors, but in buildings, no way, right? Buildings are legacy systems. You have different building management systems. You have different pieces of equipment out there. So it's really quite a diverse and heterogeneous environment with thousands of assets per building. So if you think about just even the HVAC system, you have a typical skyscraper, typical building might have central chiller connected to thousands of assets, sensors, air ventilation systems, rooftop systems. So it's actually quite a complex operational environment. And then within that, you have the time series data coming from these systems. So fine, you can connect these systems, but what you don't have is all the operational context around that. So what Carrier is doing is investing in building a platform, a shared services platform that they can use to roll out innovative services on top of. And that platform is called Carrier IO. Carrier IO is built on AWS. And again, the idea is to be able to scale new digital services to try and address some of these challenges. So how does all of this map with those keys to unlocking business value? So again, we talked about building as a system and connecting to all those disparate data sources. The way that's working is through what Carrier calls their asset modeling service. And this is really at the heart of the digital twin application that's driving Carrier IO. Asset modeling service is the piece of the system that creates that semantic data model that stores relationships between systems and between spaces and enables queries across disparate data sources. So what do I mean by that? On the right-hand side, you have an example of a schema. This is actually coming from the BRIC schema, which is an ontology that's many of our customers in the building world are using to start modeling building applications and spaces. And really the BRIC schema is gathering information about the assets in the building, where they are, their location, what they're related to, and what their function is. So if you have something as simple as, hey, I've got an anomaly in the air quality in a given room in a building. So what might you ask yourself? You might want to know, well, where is that room? What systems are connected to that? What's feeding those systems? Have I gotten a similar anomaly in anywhere else? What's been happening over the past 7 days, 14 days? You start to see that you're actually building up a number of queries across different data sources and different systems. And so what TwinMaker is doing is helping Carrier, A, to store the metadata around these systems and to build that ontology and store that in the AWS cloud. And secondly, to be able to go through that, traverse that map, and then actually query data coming from sensors, actuators, and maintenance systems in the building. So on the left-hand side, what you're seeing here is an example of that in action. This is an early example of the visualization of our digital twin application. This is in Carrier's world headquarters. And what you've got again is the time series data coming through, air temperature, air quality, CO2, radon, all projected onto this 3D spatial view. So again, it's not enough just to have the relationship mapping. You need to find a way to visualize it, to find a way to serve it up to end users. And that's what TwinMaker is helping Carrier do. So what's the impact of this? Well, Carrier is on this journey to build Carrier IO as a platform, and that's going to enable much faster innovation for their new digital services. Two examples are, one, an HVAC chiller monitoring system based on AWS services, which is going to allow them to serve customers better, to predict failures before they happen, and to solve problems in the first time. And then another system, which is called Abound. If you look up Carrier Abound, you'll see this is a smart building system and building health monitoring system. And so both of these new applications are being driven off Carrier IO. So we've talked about factories, we've talked about buildings, but what about the construction world? What about the part of the life cycle where we haven't yet built something, but we're actually in the process of building it? And in this case, I want to talk about John Holland Group. John Holland is Australia's leading infrastructure, transport, and construction engineering firm. And we've been really privileged to work with John Holland. They're one of the most innovative groups in this entire space. And again, leading into innovation on AWS. One of the things they're looking at doing is getting a better understanding of the construction environment for the purposes of environmental monitoring. So if you think about the world of construction, if you think about building a new subway line in a busy urban center, you've got to think about things like noise. You've got to think about things like dust and air quality. And there's regulations and standards that govern how much and when you can emit noise and dust pollution. And you need to be able to prove that you're operating and complying to these standards. So John Holland has environmental managers whose job is to do just that. And these environmental managers have a hard time bringing, again, all of this data together and contextualizing that. And so what John Holland has talked to us about is, hey, could we build a construction twin? Could we build a digital twin of the construction environment that monitors all of these data sources in real time and provides our environmental managers context on what's happening, gathers this data and stores it for compliance purposes? And so this is where we're working with John Holland today on the construction twin project. Fortunately, I don't have any, I can't show you the example view of the construction twin. That's something that will, that'll stay confidential now. But what we are doing is working with them on the business impact of this, and we're working with them on this construction twin. What it does is actually takes, again, those data sources. So we've got sensors in the construction environment that are taking air quality, that are taking noise, taking vibration from the construction environment, and they're plotting that against a representation of the built asset. And that representation is coming from a BIM model, or a building information model. And so what we've been able to do is actually take that BIM model, again, read from it the relationships between, read from it basically the knowledge graph. So we read from it all of the assets, and we build that knowledge-based view of the entire building. And we also build a 3D view as well. So we build that envelope of what does the building look like, and then the data is being plotted over top of it. And that gives that construction manager really that 360 awareness view of their operation. So the business outcomes here: improved environmental compliance. So being able to actually show that the construction project is within those thresholds and being able to prove that with investigative claims. And so John Holland is really starting on this journey with us, and we're looking at more and more use cases and examples of how we can really impact their business through digital twin. So I want to switch gears now. And we've talked about 3 customer examples. I want to talk about our partners and how our partners are driving innovation with digital twin. So one of the first questions to ask is, why partners? Why are partners so critical to our customers' digital twin journey? Well, we know there's 2 reasons. First of all, we know that digital twins are really about bringing together different data sources. And so it's really important that we work with partners who are bringing about or delivering those data sources to our customers. So whether it's visualization, reality capture, whether it's simulation, whether it's modeling, what we're trying to do is invest to build elegant integrations with third parties, with our partners, so that our customers don't have to do that. So we see a few examples here on the right-hand side of the graph. And then the second piece is, so our customers, to actually drive and develop these digital twins, they're looking for subject matter expertise. They're looking for guidance. They're looking for solutions. And that's where we work with the best services partners and system integrators in the world. We work with some of the best software and hardware vendors that deliver these solutions. So whether it's Radix Engineering, who will help our process manufacturing customers spec out a new plant, bring that data into the cloud and drive the digital twin, or whether it's Procore, whose cloud-based construction management platform is helping our customers manage their construction projects. This is really a big part of how we deliver value to customers. So I want to give 2 examples of this. So the first is Siemens, and I'm guessing for most of you, you're familiar with Siemens as an entity, Siemens as an industrial giant. What you may not be familiar with is Siemens as a software vendor. So Siemens has a portfolio of software solutions that they call Accelerator, and these are cloud-based software offerings that really help their customers govern the entire manufacturing operation, from product design, product development, all the way through production. Today, Siemens accelerator platform runs on AWS and uses over 60 AWS services. And so with AWS IoT TwinMaker, we're really excited to work with Siemens to think about how can Siemens leverage AWS IoT TwinMaker and how can we partner together to drive some of this integration on behalf of our customers. So what we did is we put together a demo digital twin of a cold brew coffee plant. So I'm going to warn you, there's quite a bit going on in this demo, but I'll talk you through what we're seeing here. So the screen that you're seeing is a Siemens Mendix interface. So Siemens Mendix is a low-code application platform that allows citizen developers to bring together dashboards, insights in a low-code manner. And what we've done is actually integrated a whole user experience with Siemens Mendix. So you saw on the prior screen sort of an overview of plant operation. Here we're actually driving into a digital twin scene using AWS IoT TwinMaker. What you just saw on the screen was that orange widget flashing. So there was a process anomaly that the user is able to actually click through and investigate. And here you see a video feed of this robotic arm. You see some event logs coming through, and you see the user basically investigating the situational view of, hey, what's going on here? So now we want to go a level deeper, and here's where we get into the depth of the accelerator platform from Siemens. So one of the views you might want to have is, hey, let me break down this robotic arm. Let me see some of the component pieces and how they interact. Let me see how this behavior is, coming towards my expectations or whether it's deviating from my expectations. So we're looking here into kind of a broken down view of that robotic arm. We're looking into some time series data, and we're able to go further. So we're able to look at data coming from Siemens MindSphere, which is Siemens industrial IoT platform, which is giving us a very rich contextualized view of time series data for our entire operation. And here we're able to drill down and take a look at that specific piece of equipment. The other thing we might want to do, and this really kind of gets into the digital thread, which is, hey, can I actually look at the makeup of this robotic arm? Can I understand the components, the life cycle view of this piece of equipment? And so here I'm really drilling deep into the robot arm assembly. I'm looking at the component pieces. I'm looking at the life cycle management view of how this was built, what changes were made. So basically, again, really investigating deeply some of the causality around the alerts and anomalies I'm seeing. Another piece is simulation. And here Siemens has an offering called XDT, which really allows us to package and execute simulations in the cloud. So one of the things that we can do here is think about simulating events and measuring those simulations vis-a-vis what we're actually observing in the field and comparing the simulated output with the measured reality. So what you're seeing is really rich user experience that combines a bunch of different aspects of digital twin. And just to kind of give you an overview of how that looks from an architecture perspective, if you walk from the right-hand side to the left, think about Siemens Mendix as that front end of the user view. Think about the accelerator platform as that portfolio of digital services. And underneath the hood, what we're doing is leveraging AWS IoT TwinMaker, again, to model that asset, to store those relationships, and to help visualize those live operations. We're also leveraging tools like manufacturer execution system from Siemens, materials planning tools and materials planning solutions, as well as cameras coming from Kinesis video streams. So you've got a whole slew of data sources here coming together to deliver this experience. Another partner I want to call out is Matterport. And I talked about Matterport earlier in the context of the work we're doing with Invista. So Matterport is a spatial data company. And really what Matterport has done for customers is made it much, much easier and faster to be able to capture spatial reality, to capture the real 3D view. And this is important because for our customers in manufacturing operations, they often have models, engineering models of their operation, which aren't necessarily reflective of today's built reality. So it's really important to augment that CAD model or that BIM model with what is the situation on the ground. And Matterport is helping our customers do that at scale. There's a short video that kind of explains that. And if we look into this, what we're seeing is that Matterport scan of Invista's operational environment. What we're seeing is that plant floor reality augmented with UI widgets that give us data, both live data as well as contextual data on the manufacturing operation. So this is a really, really useful view for that operator on the plant floor to be able to contextualize data coming from these different systems. And where we're going with Matterport is to be able to integrate that into a digital twin with AWS IoT Twin Maker. And so here, what you have is that spatial view, and then on the left-hand side, you have that asset view. And the ability really being able to navigate between the two, interact between the two is what's giving our customers a lot of value. So this is an example of us partnering, innovating together on behalf of our customers to try and drive some of those business outcomes. So we've talked about why now. We've talked about the innovation happening in technology that's driving digital twin. We've talked about those 3 keys to unlocking business value: getting that data, modeling that data, representing that data and that asset, and then serving that up to end users at scale. And we've talked about some customers who are doing this right now with us using AWS IoT Twin Maker. And we've talked about how we're investing together with our partners to drive this even further for our customers. So if you're in the audience now and you're thinking, okay, what is my next step? I want to go further here. If you want to learn more about AWS IoT Twin Maker and really get into the guts of that service, what I'd encourage you to do is just go and Google GitHub AWS IoT Twin Maker. And what that's going to bring you to is a real getting started experience where we've basically built a cookie factory, released all the open source, all the data, the source data for that cookie factory in GitHub. So you can actually kind of build your own operational environment, and you can really get into the guts of using AWS IoT Twin Maker. If you want to have more of a discussion on my organization, I want to take the next step. I want to understand more about how I can drive innovation with digital twin. Please feel free to go to AWS for Industrial and click on the Contact Us, or of course you can just come and speak to me. So I'll be standing over here right after my presentation concludes. You can speak to me, or you can feel free to reach out to me using my email there or on LinkedIn. I'm the only Brian O'Flaherty Wheels on LinkedIn. I want to just quickly call out from a skills perspective and skill development perspective, over 500 free digital courses and certifications available. So if this is something where you're looking to invest or looking to invest with your organization, please take the capture here and take that next step. And I want to conclude by saying thank you. Thank you for your attendance and your attention. Please don't forget to fill out the survey and let us know what you liked and what could have been added to make this more helpful to you. Thank you very much.